Dense irregular connective tissue. The bulk of this tissue is made up of two types of fibers, elastic fibers and a protein fiber called collagen. You can also find fibroblasts by locating their nuclei. You can find dense irregular connective tissue in several places within the body. One section is the dermis, which is a layer in the outer skin that's between the epidermis and the deep subcutaneous tissue. You can also find it in the sclera, the submucosa of the digestive tract, and in fibrous capsules, such as the periosteum, which lines the outer surface of bones, and the perichondrium, which is a protective layer around the cartilage of developing bone. You can also find it in the fascia. Fascia is membranes around some of the muscles, nerves, and blood vessels. There are several functions for dense irregular connective tissue. This tissue has very high tensile strength. It binds various tissues together to form organs, and it provides strength that resists the tearing of the tissues in all of the directions equally. Here is our slide of dense irregular connective tissue shown with the 4x objective for a total magnification of 40 times. What we can see here is the epidermis, the subcutaneous layer, and the dermis. Now the dermis is what contains our dense irregular connective tissue, and at this magnification we can see a few of the collagen fibers. We can also see some parts of sebaceous glands and their ducts, but to see anything else we're going to have to go to a little higher magnification. Here we're using the 10x objective for a total magnification of 100x, and at this level we can see these collagen fibers. Now notice the collagen fibers don't all go in the same direction. This provides a very tough and strong tissue that underlies the epidermis that provides support and strength no matter which way the stress occurs. Here we can see some collagen fibers, and this is the first time we can really clearly see some nuclei of the fibroblasts. If we go up to the 40x objective, we can see the collagen fibers very easily. These are the protein fibers of collagen, and we can see some fibroblast nuclei. Here we've increased our magnification using the 40x objective for a total magnification of 400 times, and we're going to look at the same structures that we looked at the previous magnification, only we can see them a little clearer. Here we can see the protein fibers going in many different ways, giving equal strength in any direction that the tissue is pulled or stressed. And we can see the fibroblast nuclei very clearly here. This wraps up our discussion of dense irregular connective tissue.